Good evening. Welcome to our webinar session today. I hope you all had a great summer vacation or summertime. And yeah, thanks for joining again. So as always, you are invited to post your comments in the chat. I hope that audio and video is okay. If yes, please give me a quick yes, okay in the chat so that I know that you have audio and video running. You can hear me? Just give me an okay, please. And then I would like to start. I would assume so. So today, this session, maybe you have seen already, I've pushed a major update and upgrade to the productive system over the weekend. And today I would like to guide you through the updates which have been happened. So I'm very excited about that. So I will start to give you first quick update what has happened. So as always, you can also read the change log here on your own. So this is our documentation here, and this was just pushed yesterday. So what has happened? So first of all, and this was a request you all had also during the last weeks and our talks here, so that also for the Yahoo data feed, you can now chart and load weekly data into the scanner. So which was before more or less with Quandle, but today we can also do this with weekly data. So let's show you how it works. So if you open whatever symbol with the cycle scanner from the Yahoo data set, so this is now daily data. And if you like to have weekly data, just add the minus W. And using this symbol, it's just a warning here. So now you have weekly data here charted. Yeah. So that's quite interesting because I think a lot of you also want to analyze weekly or longer term cycles. So I think this is now nice that we can also use weekly cycles. Yeah, it's just a small thing, but I think this might help you adding weekly data here. So okay, that's one thing. Another thing is I've made it a little bit more easy to load different ranges of data into the cycle scanner. So if we switch over here, let's do this with daily data first. Normally, you just would have clicked the load more data, and it just loads more data from the history. So now we've added a kind of selection here, so you can always add one more year, moving into the past. So this will always load another year. But you can also say, okay, I want to have a full period of 5 years now charted here. So if you just press 5 years, you will see that it will now load the full period of 5 years here into your scanner. So this, I mean, it's just a simple user experience topic, but I think it would make it a little bit more easier. Yeah, and as we are here, I mean, and if you're a new user, please be aware that the light blue data here is the out of sample data. So when you add more data to your chart, as I did here, always ensure that this is not automatically put into your analysis. If you want to update your analysis, you can add the full range to your data, or you can adjust the left-hand side of the starting point here, click it, and then you need to press refresh. So now this in-sample data has been updated depending on the time frame you want to use into your application here. So that's in regards to some simple changes. I mean, this is kind of basic signal processing. We have the Savitsky go-live filter for smoothing data. I don't think it's as much important, but at least to any signal processing engine, this is kind of standard processing. You can activate this also. Let me show you. So the settings have been upgraded. I will talk about that in a second. So what you can do if you go to the settings panel, you have the pre-processing here, and there's a new option which allows you to activate the Savitsky-Golay signal smoothing as pre-processing before the cycle analysis takes place. This is what a lot of other tools use for pre-processing here. So if you turn it on, let's see what happens. It's charted here as a green line on the chart. So you see here it takes the noise out of the data here. So and the pros out of the Savitsky-Golay smoothing here, it will not distort or delay the turning points. So it's not kind of averaging or smoothing. So that's, I think, the main purpose of the Savitsky-Golay. So the turning points, as you see here, if you zoom in, will not get a lag of this data set. So I think that's the good thing. So you can use it as a pre-processing technique without adding lag to your data. And you see here in the blue is the raw data, and the green is the smoothed one. I mean, you see these are, it will not change the cycles detected, but as you see, the noise has a much lower rate here. So the differentiation between signal and noise is much better. With applying the Savitsky-Golay filter, my research shows that the current cycle analysis engine is at least as good, and it will not much change the way how cycles will detect it here. So, but you can test this on your own, switch it on, switch it off, check how this will impact the cycle analysis. It's a nice feature. I use this also for different other topics which are important for smoothing. So I think it's not much important if you turn it on or off. So I mean, it's there. You can try for yourself. I would not really recommend it to use it. It will not change the signal. So my first observation is the detected cycles will not depend on if you have the Savitsky-Golay on or off. So at least it shows that the cycle and detection engine is already as good as it is in detecting cycles. But at least, yeah, it's a new feature. And the other topics, these are the more important ones I want to talk about now a little more longer, because these are really new features which are not quite everywhere available. So let's talk for a second about cycle skew. And I've made an article on that. So you can read the article later on your own, but I will just get you the main point here. So dealing with business or economic data sets, and this is scientific research which is available there, we see that cycles observed in economic data sets are not symmetric anymore. Symmetric means you see the classical sine wave style cycle. During the last 10 to 20 years, it has been observed that the booms or the up phases are smoother and longer, while the downturns are very sharp and shorter. So this is an asymmetric cycle, and especially this is related to economic data sets. And if we talk about economic business cycles, we talk about then stock market cycles. So the skew is not related to any data set. So it depends on what data set you are analyzing. But if we're talking about financial economic data sets, and I've referenced a lot of further reading here. So this is not my research. There's a lot of scientific research out there during the last 5 years. So feel free to browse the research on that topic. What's more important, without going into the details here from the scientific point of view, that we can now do this with our cycle analysis tool. So what does it mean? So the green cycle here is a symmetric cycle. Yeah. So the green one, the recession phase or the downturn phase has the same length as the expansion or up phase. So this is what was used 50 years ago. So this was the research for measuring business cycles in the 1950s. And to be honest, mainly every cycle software still relies on symmetric cycles. What we've learned during the last 30 years, business cycles are not symmetric. What's the asymmetric business cycle? And this is shown here on the right-hand side. It's the red one. Yeah, it's compared against the green one here. So you see the red one, I mean, it looks quite similar, but you see that the downturn or the recession, which is shown here, it's quite shorter in regards to time. So the downturn happens in a very shorter time period of time, and then the upward phase is double as long as the downturn, and then runs a little bit more longer, and then this skews this to the right side. So this is called the asymmetric or three-phase business cycle, however you call it. But what's important for us, if we want to chart cycles, we should not use the classical sine wave formula, your composite cycle, dominant cycle, whatever you use in a second. We want to apply this kind of skew here. So what does it mean? So if you read the article, you can see this on your own. I mean, this is the symmetric cycle, which you would expect in any charting tool, which is also in the cycle analysis program here, with the situation we had some days ago. So and if we add now the skew factor to the cycle, it looks a little bit different. What you can see here now. So the downturns are shorter, sharper, and then the upturns have a little bit longer and have more time to the right. So the important factor is here that the cycle length is the same. So the skew, you need a kind of formula without going into the math here, which ensures that you use the same length for these cycles which have been detected, and not disturb the full cycle. So we will just adjust the timing that it comes into this situation here. And then, I mean, you can do your own research a little bit, and then you see it fits much better to at least economic data sets or stock market data sets if you add a kind of skew here, because we all know that the downturns are very sharp and short, and the upturns go more to the right. And this applies because at least during this point in time here, when I put out the cycle with the length of 170, and then I share this kind of chart to colleagues, friends, or in the media, I always get the feedback, yeah, this cycle was not on time. I mean, the top here was more to the right, and the bottom came in more early than the cycle predicted. Yeah, sure, from the visual point of view, that's absolutely right. But it's not unusual. And that's the skew factor and the asymmetric cycle, and this is what others have researched is. So it's not unusual that the top will come more late compared to the symmetric theoretical cycle. So this is just an unusual case here that we overshoot the theoretical top here. And then that the low comes in more early than the standard symmetric cycle. Yeah, this is also more or less expected or standard behavior if you make yourself familiar with these kind of research related to skewed business cycles here. So at least from the picture, it might not look good. And I mean, you're all looking for what's the best timing for tops and lows here. So I agree that from a visual point of view, this is not good if you just look at this point in time here. But with the additional knowledge, this is nothing unusual. But now to put this into practice, it allows you now that you don't need to do it in your head. It can now be done on the chart directly with the skew factor here. Okay, so there's more theoretical knowledge behind which you can share. The formulas there, it's also the code there, so nothing special. What you need to understand is which kind of skew to add. So there's just one mass score you need to apply. But let's get over to the tool. How does it work? So this is the standard cycle you all know from the cycle analysis tool set. And there's then in the configuration, there are now different settings. So we're talking here about the cycle scanner and about post-processing. So after the cycle was detected, we want to apply this kind of skew to the cycle. So we go to post-processing. And now you see here's a new configuration you can apply. The cycle skew by default, it's off. So you see what you expect from the past. But you can now activate the cycle skew here. So I will just edit. I will not talk about the factor, just update. And you see now the skew has been added. The standard factor is based on the assumption that you have this kind of normal business cycle. So it's a little bit asymmetric to the right, so that booms a little bit longer and downturns are shorter. So you don't need to deal with the math here. If you want to squeeze it more to your needs, please read the article and you will know what to do. If you want to turn it off, for sure, just disable it and you're ready to go. So this allows you to add this kind of skew. And for sure, what's then important is if you it's not only one cycle. So if you make your composite cycle plots, so the skew factor is added to all individual cycles. So if I now add the cycle skew, this is for sure also possible with these composite cycles here. So I mean, this shifts all cycles with it. So this will also then influence the composite cycle plot here. So I think this is important to get more real to current market behavior. And at least that, I mean, it's not invented by me, but if we want to follow the latest research on economic cycles, we need to implement it, and now we have it. Okay, so that's another topic. So let's get back to the changes. So that was the cycle skew I want to introduce. And then, yeah, there's another very, very important feature which has also been added, which we need to talk about for 5 to 10 minutes here. It's the so-called spectrum plot. I mean, you know the spectrum plot below the chart. We will look at it in a second. But there are different versions how you apply this spectrum plot. And I've now implemented an alternative, which is very important because it has additional features. And I need to explain you what has happened here. Okay, let's start with the outcome before I explain it a little bit. This is the normal spectrum you see in the cycle scanner if you scroll down below. And you know we are looking for the peaks in this spectrum here. And in our last session, I explained these feature extraction, what the triangles mean, what the green color and the red color, and what the size of this triangle is about. So these are important features. Please review in our latest session if you've not seen it. This is not what I will talk before. But what's always important is here, we have these little peaks here down below, yeah? Which are also detected cycles, and they show up in the table here on the right. So in the table, you see all these little peaks from the spectrum chart. And what spectrum averaging is about, this is applying kind of smoothing on the spectrum. So you know, a lot of people dealing with cycle analysis apply pre-processing algorithms, which will impact the raw data. And I think this is a bad idea because we distort the raw data we will put in the center. So therefore, spectrum averaging means we smooth the detected cycles afterwards, but we will not change the input signal at all. So that's important to understand. It's a kind of different technique. And this helps us in the end. We run different spectrum analysis and then smooth the outcome. And if you have a look at these little peaks here, this makes the spectrum much more cleaner. You see, it's the same data set. What I've shown you above and now below here, this is the same raw data, which have been put into the scanner. But I think clearly from a visual point of view, you can see here that the peaks are more sharp and clearly seen. And the little peaks here down below, which have been higher in the other ones, are much, much smaller now. So the difference between cycles, which are not really important for cycle analysis, have become much more lower. And the cycles which really influence the data set have more clear peaks, which is important for us if we do cycle analysis and cycle forecasting, because we are always looking for the cycles which are important in the data set in the present and looking into the future. So this will help us a lot moving forward. We will see this live in a second. It's just important to understand. I will recommend you that there's also the article on spectral averaging. So if you want to understand what's happening, please read the article. I mean, this refers also to a topic, and if you're a long-time follower about our tool set, I always talk and teach you about that cycles are not static, and this is where we need to be careful. So if we do a dominant cycle plot or composite cycle plot, it assumes that this is a static forecast into the future and from the past. But we all know cycles don't behave that way. So, and the spectral averaging helps us there, because the power spectrum, we do more or we do different periods and calculate the spectrum for different periods of the data set. And if you remember, in the past, for the standalone whentotrade software, you had to select the point in the past where the analysis needs to start. And depending on where you put the starting point in the past, sometimes you see different dominant cycles from the output. And this was a very, from the user experience, a very complicated thing. And I've put this out of the current tool set, so you don't need to deal about where to put the start point of the cycle analysis. So the end point is always fixed to where we do, or you can do it on your own with fixing the data. But spectral averaging now changes where the analysis starts a little bit. It does not change the endpoint. The endpoint stays selected because we always want to get from the current point into the future. But then it slightly changes the endpoint, or the starting point from the past of the analysis, runs different spectral analysis on these different data sets, and then is doing the averaging on the different spectrums which have been derived from this information. So and that's the feature which gives us better information, because it uses different periods of input, and then smoothes the outcome. I mean, it's all explained here, and let's now switch over how to apply that. It's also now in the settings panel, and the cycle scanner, if you go to the configuration, has now two different selections which you can use. So the Amplitude Spectrum is the standard version which was there for 20 years. So this is just the pure spectrum you all know about. So I will just use this version here. So this is the spectrum for the current chart and analysis, and you see it's always the case. You need to pick the right cycles. I've explained you in the last session, this is very important. If you have not seen it, please visit it. What's the purpose of these triangles, the color and the size? This is very important to select the cycles. But now let's talk about the average power spectrum here. You can activate this here. If you want to see both, you can also activate to show both spectrums here to see the difference, what's now interesting here. So let's just update it. So what we now see is we see both algorithms applied here. I think you can see it in the, yes, you can see it here. So you clearly see the top is the standard spectrum plot here, which you see, and the average power spectrum here is shown down below. So you see here all the little wiggles, the smaller cycles, the noise has been taken down. There are not so much peaks at all as here, and the real peaks are not distorted here. They really stand up here on top of that. So it will not filter out the important ones. It will give you kind of better indication or what are the real cycles to pick if you deal with composites here. So you can chart both. I mean, it's just to compare both. Finally, when you decide what to use, you don't need to do both. The one which is selected here is used for calculation. So the visual point was just to show both. The one you select here is then always used for the calculation and detection here. So I will now switch only to the power spectrum. And then what you see here, this output here is then also used for sure. I mean, standard as always. Here's the spectrum. So you can now decide if you want to stick to the old version or use the new version. it's happy to do. And I mean, this is what I added, why I added the Savitsky Go Lie. This is then another feature to smooth a little bit the spectrum. So I don't use it in pre-processing, so it's off, but it also helps to make the spectrum and cycle detection smoother. So this was the real reason why I implemented this signal processing feature. So what I'm using today, and this is, I would recommend use the average power spectrum. That's quite more advanced, more stability at the spectrum smoothing to filter out. And this is kind of state-of-the-art cycle analysis. So this is how you should configure your settings here. And then it's quite more easy. You don't need both on the chart here. Yes. And now the final thing in regards to the configuration. I mean, you might have seen that the configuration panel has changed a lot. So we have different options here. I mean, the Cycle Explorer configuration is also there. Some post-processing, which I will also explain in a minute. But what's really important is, and I think this was also another feature you asked for, to save your settings. You know, I mean, you always load the cycle scanner, then I don't know, on the next day or 2 days, and then you're left back with the old settings. So now you can save your settings in 2 profiles. So profile 1 and profile 2 means you have 2 kind of boxes where you can store your settings here. And once you're fine with your setting, I mean, you need to select which profile to use. You put your settings there. So Cycle Explorer, post-processing, and when you are fine, just to demonstrate, I will also add the cycle skew. And if you press set, this will now start as profile number 2. Yeah, so I will now press set, and it's now saved as profile 2. So, and this is your preferred profile now, which is also selected if you get back to the cycle scanner. So you can always deal, if you now get back to the cycle scanner, this profile is also always used. You see the cycle skews also done. So just for demonstration, let's also set up the profile 1. So profile 1 will then use the old or the classic amplitude spectrum. Will not use the skew. I would say set to save it here. And now I have 2 profiles. And if I don't want to change the settings, you can quickly switch now between 2 profiles. So if I just click here the profile 2, let me just wait. It should have, now we have exactly profile 2 is used. I mean, it's just with the blink of an eye. It changes just as we go. If I get back to profile 1, you see here, it's directly adjusted here. So just with a click, you can switch the analysis with the pre-selection without the need to open the settings panel here. So, I mean, I think 2 profiles are enough. So, you don't need to save 5 or 6 profiles. At least, mainly, you will have your standard profile. Mainly, and this is what I'm doing currently. I have the profile 1 is, as always, just the setting as it was before. Before the new features came in. And in profile 2, I set it to the new setting, so I can quickly switch between, is there a big difference between the old and the new ones? But you can adjust it to whatever need you want. I mean, this will give you quite lots of flexibility. And if I go back and open a new chart, then go to the scanner, you see it's always selecting profile 2 now as standard. Yeah, so it's always using what you have used in the past. So you can also be sure the profile and the settings you have will always be reused. Yeah, and last but not least, on the settings topics, what I have not discussed is, and this is also important to understand, it's not so easy. I hope I can bring this across. So let's use here kind of overload a little bit more data. Use all data for the analysis. So now we have a 5-year period for the cycle analysis. It doesn't matter if it's the power spectrum or the amplitude spectrum. And this was, I will use now, plot the dominant cycle. I will turn off the skew factor for a moment. to do this. And this is now plotted into the future. I mean, this is what we're all interested in, kind of getting into the future here. What you need to understand is the analysis of this cycle length here was done on the full range of the data set here. So we have now put 5 years of data into this detection algorithm. And then the detection algorithm came back with a length of 174. But you always know what happened here? I hope that still audio's there. It's just, please let me know if we've lost audio, but I will continue. So it's not only the length what is important in cycle detection, it's also the phase what is important. You know, the phase shows you where we are in the cycle. So the length of 174 is the distance here between the top or lower low. But the phase tells you where we are in this cycle here. So if the top is here, 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 or here on the time scale. So the phase is not shown here on the table, but the phase is important because the future plot will not only determined by the length, also by the phase. And there are 2 ways now to do this. So in every normal analysis, the phase is now detected based on the phase it detects here on this full data set of 5 years. But as I often tell you, that the phase is shifting over period. I mean, the cycle scanner takes this as a static data sets, yeah. But the phase is not the average what it was during the last 5 years. So this is what you use if you use the pure function. So this is what you use if average cycle phase. This means that for the forecasting, for the phase, it will use the average phase if I look to the full 5 years of data set. And you see this is 1, 2, 3, 5, 4, I think 6 repetitions of the cycle here. If you're familiar with cycle analysis, you know that mainly the current phase, let's say within the last year. So there is a cycle with a length of 174 days, was in this case. But the phase will shift, and the phase today, or the phase in the year of 2020, where we're talking about, might have shifted in regards to the average cycle phase, just looking at the past 5 years. And this is now what you can do, so that you say, okay, I will use the full data set to detect the cycle with a length of 174, but I will now only use the current most related data set to detect where we are in this phase today. So not using the average, using just the phase of more or less the current time frame. And this is the configuration. If we switch to the current cycle phase, it will not adjust the length, and it will not detect any other cycle. It will just check if the average phase, which is the normal output of a kind of spectrum, might be different if we just look at the current past, yeah, just take into account the last year or the last 2 or 3 repetitions of the cycle. And this can be activated by doing this. We will observe it just a little bit. So I will a little bit zoom in to make it a little bit more clearly here. So this is now the current phase, and this is slightly more adjusted to the current behavior of the cycle. So here the peak is around 18th of August. Yeah, you see it here, 18th of August. Let's change it now to the, or let's use our average cycle phase. You see it's now switched, yeah, to the 25th cycle. So I mean, it's not a major difference here, but at least, and this is what dynamic cycles are about. Yeah, you have slightly phase shiftings in the real data, real phase. I mean, this might not be important if you look at this time here, but the difference in phase, the more you go into the future, the more important it is that you have the most recent phase, because then the deviation, if you go into the future, will become more and more bigger if you don't have the right phase. So even if it has not a much difference here on the current, it's very important moving into the future. I think I've written a lot of articles, just going back to the documentation, which I always would recommend to have a read about that. I think I've written, an article, and I think it's from my book, but I'm currently converting the print book also to a digital version. So I explain the importance of phase shift here in this article, and you see this, the red one here is the same, at least now this is the length shift here, but this is the phase shift here. So, and if the phase shift going into the future compared with length differentiation, I think take your time on your own. But this video shows you that just looking into the future, that the difference in the future will be very, very important. But okay, take your time on your own. I think we don't need the video here to do this. Again, it's also not a very big different feature. Yeah, just to tell you, I mean, the cycle analysis framework has not changed really in general, but at least it's also a kind of simple feature to give it a better, to tweak the optimum and the current situation here. So, but we can make a quick test here just to show you. Let's use the profile with the average cycle phase. Let's use the average power spectrum. Let's set it here, and let's now use profile 1 also with the average cycle spectrum. But now with the current phase. Just a second. Set. So profile 1 is average, profile 2 is current. Profile 1, I want to have the same here. So profile 1, profile 2 is the same. Profile 1, profile 2. Yeah. So I just want to do this because this is now what you can do. We can quickly switch between current phase and average phase just by clicking. Now you see it more nicely, I think, if you just look at the top here and I switch. So this is now the average, and this is now the current. So here you see, how it's slightly changing, and this is how you can use the configuration and the profiles. Yeah, that's the important topic I wanted to introduce to you today. I think this is it's quite important. I mean, it's not only helping us in getting better cycle plots into the future. I need this, and I'm working on this mainly because I need better spectrum data, because these spectrum plots will be put in a machine learning algorithm later on. I've not finished this yet, but this is why I tweak it a little bit. So the takeaway for you here for today is that the cycle detection engine has not changed in total. Yeah, it's still the same cycle detection with my Goertzel algorithm, which will tweak out the cycles here. It works for over 20 years. This is not touched at all. What we just now do is we just don't do it once. The spectrum averaging, it takes different cycle spectrums, applying some averaging. This helps us more getting the real length of the cycle. You can now switch between current phase and average phase, which you can tweak a little bit more to make the forecast better. And you can apply the cycle skew to be more, accurate with how current data sets behave, at least in stock market data. So moving forward, this will make the machine learning algorithm even better, but this will always help you here in cycle analysis. The question is in the chat, which I see here, if the WTT cycle application. To be honest, I'm currently focusing on evolving the online version of the cycle application. I will maintain the standalone cycle application for sure, but there will be a delay when you see these features coming into the standard application, because all the machine learning and the new features will first apply here. I mean, this is all live, so if you open the cycle tools right now, you can all use what I've showed you here. So this is not a preview. This has gone live 1 or 2 days ago. Yes, that's it for today, to be honest. I think there's a lot you can try and learn. From that, yes, what cycle skew factor? Yep, and please now let's open the Q&A session. Yeah, I would recommend to you use the standard skew factor of 0.3.5. That's more or less standard setting. What it means, or what the difference is explained also here in the article which has been referenced. And you can also, so here you see the different behaviors, and I've also linked the kind of, I call it playbook. You can all do this on your own. So this is the formula, and you can play here with different skew factors. So you see please observe the red one. Yeah, the green one is just the symmetric one. So I would recommend these 0.35. Yeah, so this is the red one. But you can see if you use other skew factors, you see how this relates. And be careful here, because a drop never happens in 2 days in this kind of longer cycle. But so it allows you to play a little bit with it, just to see it visually. And afterwards, for sure, you can then also put higher values in here. But as said, not recommended. That's but at least this is what I recommend. But for sure, feel free to test it on your own. I mean, intraday data can be used, but not automatically. So if you want to deal with intraday data, you need to upload this data set first. So for sure, you have the option to upload your own data as CSV files, but we have not integrated our data feeds with intraday data because this is much more complex. But you can use intraday data. That's not the problem. So if you have exported from your whatever platform or data feed you use, put intraday data into a CSV file Excel chart, and then upload it here as your data set, you can also use intraday data with a cycle scanner. That's not the problem. It's just not automatically linked with our data feeds we have integrated here. So there's a yes and no to this answer. Yes, so the full cycle scanner here can use intraday data. We just don't have automatically data feeds which provide intraday data. So you need to do this on your own, and you need to upload your intraday data set first on your own. But then you are able to, the cycle scanner is then able to do this. Okay, what else has changed? I mean, we will work a little bit on the cleanup on the user interface, but maybe not much to comment. I mean, all these different things will also be saved, so you can for sure the profiles will also be saved if you save the full data sets within your analysis. So I mean, this would allow you then to do different kinds of analysis. Just looking on the clock, we are running now for 45 minutes. Any other questions you want to talk about today? If not, I would recommend try out the new features. There's a lot you can do now on the settings. I think I will not improve the settings even more because as you have seen, it's just minimal changes. So it's not really a difference in detecting cycles. The next steps, just the kind of outlook, what will happen next is, as I said, I want to have better integration with tool sets like TradeStation, MetaTrader, NinjaTrader, where you can directly ring the data out of TradeStation into the cycle scanner here without the need of export-import. This is another big feature to come. And I'm working on the machine learning where machines detect the cycles and not you with latest deep learning algorithms. But just an outlook, I think maybe, looking at the end of the year, they will show up more. For today, I would say, as is that lots of topics to play. Please read the articles when you play with it to make yourself comfortable. And thanks for taking the time today with me. And we will meet for sure every month here. So I would love to see you in 4 weeks here. Have a nice weekend. Have a nice evening and stay safe. See you.